Okay, it's given in question number 36 to find out the equivalent weight of K2Cr2O7 in acidic medium. So we know equivalent weight is molecular weight divided by number of electrons involved, lost or gained. So if you balance the equation, that is using ion electron method, it's going to go to 2Cr3 plus. So this is in +6 oxidation state, this is in +3 oxidation state. For one chromium there is a gain of 3 electrons, so for 2 chromium there will be a gain of 6 electrons. Now there are 7 oxygen over here, so for that we add water and multiply it with 7. Now to balance the hydrogen we have to add on the left hand side equal number of protons. Okay, so that is how we have to balance the equation and then check the charge on both the sides, left hand side and right hand side. If it is balanced, then the equation is balanced by ion electron method. So obviously weight of chromium over here will be 52 into 2 um, plus 7 into 16 uh, plus 39 into 2, and that would come out to be, let's calculate, 39 times 2 plus 104 plus 7 times 16 comes out to be 294. So over here it will be 294 divided by 6. That should be our correct answer. Which one of the following is a primary standard? Quality for a primary standard are following. 1 should be air stable, non-volatile, non-effervescent, non-deliquescent, should be stable in aqueous solution. Now, having considered all these characteristics, you will say for chromium, this KMnO4, it is not stable in solution. Okay, it reacts with water to form manganese dioxide. K2Cr2O7 is a primary standard because it can be stable. It is non-deliquescent. Unlike Na2Cr2O7, it is a solid substance. It can be weighed directly, and its standard solutions can be prepared. Okay, and mostly involved in redox titrations. This one. Na2H2O4, O3, it has sulfur, so that can get oxidized. Mm, and so that will not be considered as a primary standard. Sodium hydroxide is a highly deliquescent substance, so it cannot be correctly weighed. So that's why it is never going to be a primary standard. Rather, apart from K2Cr2O7, all the other are called as secondary standards. Okay. Equivalence point of titration of oxalate solution in acidic medium with KMnO4 will be, okay, KMnO4 from +7 oxidation state in reaction with oxalate solution. It goes obviously in acidic medium if they are saying, then actually MnO4 in acidic medium it goes to Mn2 plus, which is a D5 system. Okay, this is a D0 system where the color is due to obviously for ligand to metal charge transfer. So once it reacts with C2O4 2 minus, obviously in the acidic medium, it will be converted to water and CO2. So here the solution becomes Mn2 plus in aqueous solution is basically colorless. So our answer over here is going to be becomes colorless.